Fine. Few days. So let me try. Yes. Okay. So start the. Yes, Anuj. So what we are going to discuss today? So till now what we have completed? Till now 8085 architecture, all pins we have discussed, all pins completed. Okay, so hold whatever interrupts, everything is discussed. Other than this, now today we will discuss what is the meaning of instruction cycle, your favorite machine cycle, what is the meaning of T state, these things. Good evening, Hrithik. And also we discuss memory interfacing. These two things will be covered in today's class. Okay. कल का DPP में we'll do some questions if time permits. No, HLDA is required. System should accept it. Abhinay. Okay, we don't know how much time is required to complete the current machine cycle. It may be at the end, or it may be in the middle, or it may be starting. The time is not same every time. Yes, Anuj, I will upload again. Don't worry. Okay, so let's do some problems for initial energy. So we are not doing problems from long few days. So let me try. Yes, interrupt. That interrupt. Let me upload all the questions, then we can see. Okay. So let's start with the first poll. It is a simple question. All are simple questions. There is no trap today. I mean, for the first few questions. So which of the following is a software interrupt? I don't give much time. Just to it will quickly revise the things we have discussed. Good. Why 50% only? 100% आना चाहिए. क्या हुआ? So top 10. These are the people. Harsh, you are the first. So we know it. All these are hardware interrupts. 7.5, 6.5 trap, INTR are hardware interrupts. and only RSTN, that is 1 0 to 7 are software. Yesterday class I discussed this point. Why you people got the doubt in this? This is non-vectored, but software is RSTN. Okay, next listen here. The power failure alarm must be connected to which of the following interrupts? Let's start. Aapka Paula is coming. Hello, Madhuri. What happened? I am wrong. I am wrong. Don't worry. Don't worry. I am wrong. It's not trap. I made a wrong one. Okay. So somehow I made a wrong. Instead of I pressed the wrong thing. Most of you know this. It's a trap only. Trap may trap. Okay. By mistake I opted. Power failure. Any high, what we call high priority task must be given to trap. This one trap only. Try to have poll again. One more question. Let's start. Read it. I will start the poll. Okay. So let's start the poll. Hardware interrupts. How many hardware interrupts are there in 8085? It will make a quick revision of the things. So I told you already the questions will be easy if you understand the concept. What happened here? I'm not getting 100% answers. What's wrong with you people or it's wrong with me? What's happening? So yesterday I don't have much energy because I have some little headache. Now I will give you full energy. Okay. So hardware interrupts are 5, software interrupts are 8. Already discussed that. What are the 5 interrupts? I told trap, RST 7.5, RST 6.5, RST 5.5, and INTR. Okay. Hold is DMA, not interrupt. Okay. Read this question. 3 devices PQR have to be connected to 8085. Device P is the high priority and device R is the least priority. In this construct, what is the following assignments? Okay, shall we start? Okay, if you are ready, I'm always ready. Good. Because trap is there, some people are in that option A, which is wrong. So you can see the later board. I think most of you might get 4 by 4. What happened to Harsh? He is not there. You should get 4 by 4, but because of that one wrong answer, you might get 3 by 4. So what is that? High priority is P. So out of this, P can be trap, but R is the least priority, 5.5, and please see here, 6.5. Who is least priority is 5.5, not 6.5. So this is wrong. So it should be 7.5, 6.5, 5. P, Q, R. P high priorities, R least priority. I'm not saying 7.5 is high priority than trap, but in these three, this is high priority. Next question. Okay, Patel G. In the trap is one of the interrupts available in 8085. Which of the following statements is true for trap? So let's see. Let's see. Any doubt? If A was also right, you mean if examiner has given here 7.5, sorry, here 6.5, in that case, you can use A. Okay, and C also correct. Okay, but it will be giving highest priority, so you may choose it. But examiner generally he don't give that. According to this statement, it can be A, it can be any case, which satisfies this with high, this with low. So let's start the poll. What is that? Trap. Let's trap. This is both edge triggered and level triggered. Last lecture I told this also. Trap is level and edge. That table I have given full table. Right. Now let's move to the new session. I mean new topic. So what is the new topic? We'll have some more, don't worry. In the process today we'll do more questions. Don't worry about it. After completion of this, only questions we'll be doing. So the next part we are going to discuss is instruction cycle. Why I am not getting any new interface? You people told new interface is there. Machine cycle and T states. I will explain. Now listen. What is the meaning of instruction cycle? Instruction cycle is the time required. Oh, Pramit sir, you might have done some magic. Instruction cycle, I will ask sir. Instruction cycle is the time required to complete one instruction. What is the meaning of instruction cycle? It is the time required to complete one instruction. Okay, only my class it is not coming. Yes, definitely, sir. I know sir very well. Very well in the sense, good friend, right? Okay. So instruction cycle is the time required to complete one instruction. एक instruction complete करने के कितना time processor को लगेगा? That is your instruction cycle. What is the instruction cycle contains? It should read the data, decode the data, execute the data. All together comes under instruction cycle. एक cycle. Machine cycle means the time required to complete एक job. One job करने के लिए what is the time required is called as machine cycle. T state is nothing but the time period of the clock. Time period of the clock. So let's take the fundamental what we call definitions. Then we discuss little more clearly one by one with the timing diagrams also. So where is that today? I think you made it. Instruction cycle. It is the time required to complete one instruction. It includes generate the address of the next instruction. Job. What is the jobs to be done during the instruction cycle? It includes the generate the address of the next instruction, read it, fetch it technically, understand means decode, execute. So this whole is called instruction cycle. One instruction can be divided into multiple parts. What are those parts? Fetch cycle. It is the time required to read the instruction and understand, that is decode the instruction. What is the meaning of fetch cycle? Actually, the name is fetch, but in your 8085, fetch contains decode also. Originally, in advanced process, it is like this: fetch, decode, execute, memory will be separated. Then what is the advantage, sir? We call pipelining. Total instruction is divided into parts. So processor is a single, but what happens is we divide this into 4 jobs. When one instruction is getting done, another instruction will start decoding. When another instruction is decoding, another will fetch. Like that, this process is not present in 8085. It is not pipeline processor, but generally this is possible in other processors. Parallel processing, you can say. Now come here. Now come here. So in 8085, yeah, 86 may fetch and execute overlap is there. Okay. In 80, what we call pipeline, two-stage pipeline is possible. In fetch means it contains fetching and decoding also. Together we call fetch. Next, execute. It is the time required to execute, means to do the job. Machine cycle. What is the meaning of machine cycle? Let us see. Machine cycle का meaning क्या? It is the time required to complete one operation. It can be reading, writing, any job. एक job के लिए what is the time required is called machine cycle. What's happened, Ayush? I'm new here. Should I cover the previous lectures of this subject? I think try to attend if you are able to. For today's class, you don't feel difficulty. Up to memory interfacing, 2 topics you require little previous understanding. Memory interfacing you can understand. Otherwise, better to go through previous 3 lectures. It will be good. So T state. It is see here how to measure the time. How to measure the time? We measure it in seconds. Like that, we will be measuring now. Similarly, in your computer, the measure time will be measured as T state. What is the T state? It is the nothing but one time period of the clock. So suppose I ask you something, how much time you require? You say I need 3 days, sir. I may need 4 days, sir. I may say 5 months are required. Like that, you will be saying. Similarly, for computer to do one job, how much time is required? If you ask computer, computer will say, I need 3 T states, 4 T states, 5 T states. So computer measured time is measured with the help of T state. What is the meaning of T state? It is nothing but time period of the clock. Both are same. Everybody understand these fundamental definitions? Just a definition tak if you understand, then we will move further. So every machine cycle requires some time that is measured in multiple T states. So this is the order. Okay. Ayush, message me in Unacademy app once. I will reply you. Okay. We'll discuss there. It is the terminology. Why it is called fetch? Why it is called not read? Similarly, it is just the terminology followed by your processor. Okay. State diagram. You can say what we call like it is also technical only. One state to state transition, like that. One state to second state, third state. Yes, Putul, good. Not only Intel, it is a general processor terminology, not for Intel, I can say. Yes, there is a relation. This fellow is containing these two. These are measured by this. Amitabh. Instruction contains fetch and execute. How to measure them? Okay, each fetch and execute is called one machine cycle. One job is one machine cycle. Multiple jobs will give you one instruction. Yes, correct, Abhijit. Okay, so how to measure this machine cycles is with the help of T state. Now I will show you all those things. So don't worry, just wait. So generally in your 8085, these are the available machine cycles. You may have hold, what we call reset and hold acknowledge. Those things are also there. Other than that, So these are the jobs system will do for any instruction. Opcode fetch is generally 4 T states or 6 T states. Whenever I write T, you understand it is T state. Memory read in 8085 requires 3 T states time. Memory write also requires 3 T states time. IO read and IO write also requires 3 T states. Interrupt acknowledge, everything requires 3 T states. Bus idle means do nothing. Here also, yes, these are fixed. But for opcode fetch, it is not fixed. Sometimes it is 4, sometimes it is 6. When it is 4, when it is 6, we clearly discuss it. Don't worry. Good. So let's move. Let's move to the next. Okay. Yes, correct. Shivam. So now listen here. Now listen. So if you have one instruction, that instruction may be having this, or any one of these two, or two of n of this. Okay. I will write this. Every instruction contains opcode fetch and one or more other machine cycles. In every instruction, these things will happen compulsory. Bus ideal means I will tell you when we come to that part, but I am generally saying bus idle. Idle means do nothing. CPU requires more time to do some 16-bit operations. During that period, bus is not doing any job, but CPU requires more time to do what? Internal operations. During that time, computer will be in bus idle state. So is it clear? Opcode fetch is compulsory in any instruction. After that, it may follow by memory read, memory write, IO read, IO write, anything depending on the instruction we are going through. Depending on the instruction, any one of them can happen. Any one of them or more of them can happen. Is it okay? Shall I move further? Now we see one by one what is opcode fetch, memory read, memory write, etc. So let's go. Let me give you one table which we discussed as last lecture for reference. This table is there. Okay, already we discussed it yesterday. I'm not going through it now. So now I want to discuss opcode fetch machine cycle. What I want to discuss, opcode fetch machine cycle. Okay, it is the, so here generally it is just name differences. Okay, understand concept first. It is the first machine cycle in any instruction. For any instruction, what is the first machine cycle is opcode fetch. What is the first machine cycle? Opcode fetch. Okay, now listen. Let's see the timing diagram of opcode fetch. This is where people may feel difficulty. Now you may not feel difficulty after our discussion. Okay. I think wait. It is not timing diagram of opcode fetch. Good. Here, listen. This is what we call opcode fetch machines. Don't see the figure and confuse. I am there to help you. Don't worry. So see here. This is the already existing part. Don't worry about this part. This area can be neglected. Start from here. Okay, this is your clock. This is your clock, because when you are calculating time, always it will be shown like this. This in the digital, I have discussed this right already. Delays, calculation, etc. We take middle point as the reference. That point also I told when we discussed the propagation delay concept. Now come here. Opcode fetch is a memory operation. Opcode fetch is memory operation. Why? What is opcode fetch? First tell me what is opcode fetch? It is reading opcode from memory and store in where? Instruction register. Very good, Asif. Instruction register mein it will be stored. So come here. So for doing that job, computer require 4 T states. 8085 computer requires 4 T states. So in 4 T states, 4 T clocks, you can say each T state may what is the job done is explained with the help of this timing diagram. With the help of its timing diagram, we will explain. Simple rule. First thing is IO. But these are the lines which will tell you what happens in each line generally. IO. See here. During the opcode fetch, I told it is a read signal should be 0 because you need to read from the memory. From IO by M bar signal. IO means what? Input, output, or memory bar. Okay. If this memory bar signal is 0, it is memory operation. If it is 0, memory operation. If it is 1, IO operation. So it should be 0 only. Opcode fetch may this should be 0 because it is memory operation. And S1, S0 should be 1, 1. I told you already. These are the things happens. Okay. So what happens is it will during the opcode fetch IO by M bar signal will become 0. Okay. And S1, S0 both will become 1, 1. Because it is opcode fetch. Okay. And listen here. First T state may you see what happens? Your address latch enable will be 1. You understand? Address latch enable will be 1. So the program counter lower byte will be copied into the address bus and higher byte will be copied into higher address bus. Okay, there is nothing difficult. All these things you know already. We are just representing this with the help of some figure which looks complex but not complex. Okay, so then listen here. So up to now, forget it. Only in the first T state, what is the job completed? No read operation is done. Just copy the program counter into address bus. What is the job you have done? Copy program counter contents into address bus. That is, during this period, what is the job happened? A15 to A0 is copied with PC. Simple rule. Simple thing happened. A15 to A0 is copied with program counter. So who is taking care? Program counter will give you the address bus. This job is done. During opcode fetch, this is common. Okay, it is completed. After this, what happens? After this, what happens is your address latch enable will be disabled. Address latch enable will become 0. That's what I have written. That is written here. Latch low order address. Okay. Address latch enable will become 0. By this time, whatever is there, that will be stored in the latch. Then it becomes 0. Now it will not be there. That is, latch is having the address now. Address bus is not. The lower order will be connected to latch output. Now listen. The second T state, what happens is we give read bar signal equal to 0. It is active low na, we make it 0. Okay, so then it will read the opcode. From where it will read opcode? From where it will read the opcode? From this address. One by one, step by step I am explaining. Please understand that. Okay. Address not in PC, address in the address bus. Address in the address bus. PC has given and its job is done. PC to address bus ko diya, it said my job is done, you take care. Now PC can change, but still no problem for us. Okay, so PC, whatever you are having in the PC is given to address bus. So address bus only, PC will not be connected to anywhere. Address bus only connected to the memory. So address bus may whatever you kept in that address, the data is there now, that is copied into this data bus. Okay, so during this period, all what another thing also happens, that is PC will be copied with PC plus 1. No, it is not 0. It depends on the program initial address. It is not what 2 lines. I didn't get you, Rohit. This is the way to represent it. This box type of. Okay, I'm back. Some power gone. Right. So where we are, listen. This is just representing address bus. There is another way to represent also. They can represent like this. It indicates it is 8 lines. Or another way to represent the bus is like this. Okay, different ways you can represent the bus. If it is not a single line, if it is a group of lines, we represent either like this block, or you can write a line and write 8 or 10, which indicates 10 lines or 16 lines, whatever may be. Okay, good. So let's discuss. Let's continue with the discussion. Please listen here. First, listen. Let me complete. Then you can ask your doubts. So in the first T state, what happens? PC fellow will give his value into address bus, and PC will be happy that its job is done. Then that address bus will go to, based on that address bus. Once you get read signal, that address, we will go to that memory location and read the data where you have this opcode. Once you read that now this opcode is in where? Opcode is in D7 to D0. Opcode is in where? D7 to D0. Okay, wait, listen. During this time, parallelly PC will be incremented. Why it is incremented? It will get ready for the next job. PC will be incremented to get ready for the next job again, next cycle again. It can increment, still it will not affect your result. Why? Because already old PC are loaded in address bus. Okay, now listen here. Once your read bus is becoming 1, once your read is done, that is earlier read is 0, now it will become 1, means read job is completed. Then what happens is this opcode which is in the data bus will be stored into instruction register. Who will take it here? This is a instruction register will be copied with D7 to D. Very few people knows that there is one of the IES paper they have given the question also in opcode fetch. Out of the 4 T states, in which T state this job will be copied, that is the data will be copied into instruction register. Opcode will be copied into instruction register, that is a T3 state. Generally people will say it will happen in this total. Where it is happening exactly is in T3 states. Every single state we are discussing. Now during the fourth T state, okay, you don't have any job of opcode fetch. Opcode fetch is originally completed here itself. In the fourth T states, computer will do decoding job. That is, read that opcode, understand. Read that opcode, understand. That job will be done during this process. Is it clear? Okay, wait. What is the meaning of TS here? After this, your address bus will be tri-stated or high-jet, means high impedance state. High impedance. What about higher order address bus, sir? It is not specified. Not specified by whom? Your manufacturer. It can be, it may be any value depending. Okay. So now you understand these are the 4 T states of opcode fetch, but sometimes it requires 6 also. How to know it, sir? That we discuss when we discuss the instructions, but at which state it will be discussed is here. While decoding, it will understand whether opcode requires 2 more states or not. Okay. I will tell you one more thing here. Okay. Firstly, listen. These 4 T states, everybody clear or not? Please tell me. This is your opcode fetch machine cycle. Good. Now you don't have fear of the timing diagram, am I right? Yeah, see here, if you are doing input output operation, then this IO by M bar signal will be 1. So, but here you are doing memory operation, now this should be 0. Because opcode fetch is memory read operation. Good. So see, these are the things we have discussed just now. Please listen. Opcode fetch machine cycle. What are the status signal? IO by M bar signal should be 0. S1, S0 should be 1, 1. Please listen carefully. PC is giving the address, whatever it is loaded with that particular address PC will give. You are the person who is loading the PC. It can be at any location depending on your program. Wherever your program is there, there we write it. It need not be 0. It can be 2000, 3000, anything. Initially, we load the PC. If a reset is pressed, the PC becomes 0. Now come here. Step by step analysis. First T state, what happens? First T state, address bus is copied with the higher order PC. Okay, lower order also copied with the lower order PCL. Address latch enable will be 1. This line is clear na? Now no doubt. Second T state, what happens? Read bar signal is 0. Read bar signal will be 0. I am initiating the read operation. PC will be incremented by 1. And your address bus, okay, now A7 to A0 will be used as a data bus is copied with the memory contents of the address bus. AB means what here? Address. Don't worry with the don't confuse with your terminology. Okay, 87. This is what is the meaning of this? Memory contents of address bus. That is, whatever the location you are showing, in that location, what is the data is present, that data will be loaded here. Shall I give one example if you want? Listen. Suppose 25 is your opcode, 3646 is your address. What is this here? 3646 is the address. Then, what is the opcode? 25H. Just randomly taken. So during this, what happens is a higher order, that is 36 will be loaded, and here lower order. Yes, Gopi, it is multiplexed, so we use the name AD, address and data. Opcode is nothing but data, man. Asif, data is nothing separate. Data is can be containing opcode, can be containing anything. Data may contain address also. It is you you are keeping the name it as opcode. Opcode will tell you the operation to be performed. It is the machine code for the computer to do the job. How to make opcode, etc. we discuss it. PCL. What is PCL? 46. So first T state may a address bus is copied with 3646. Now it will become 3647. Now the address bus is copied with the contents of the memory. That listen first, don't type, listen. Okay, so first listen. See here, 3646 is the address. In that address, this is memory. In this memory, this is the address. What is the content? 25. Okay, so when you write the number 36 and 46, computer will go there. Address bus is pointing to this location now. So from that location, PC may be incremented, that doesn't matter. From that location, what is the contents of this location? What is the memory content of the address bus location? This 25 will come here. Okay. Now you tell me what is the, if you have any doubt, ask me. Yeah, it is in the form of data, right? Correct, Ritik? I told this yesterday, Anuj. See this table. S1, S0 will be 1, 1 during opcode fetch. Address and data is not having any relation, people. No, bus will retain it. That's all. As long as from for some time it will retain. Bus can store means it can keep it. Bus is like a wire. You give 256, it will keep that 2567. It may have some buffer. Okay, it may have some buffer. No, opcode is not address. I am saying memory can contain anything. See, yeah, good question, Asif. I will tell you. Please listen. When computer start any instruction, I told here, please listen carefully. It is the first machine cycle in any instruction. Is it clear? So when computer starts any instruction, first time whatever it read, it will read it as opcode only. It is reading some data. Okay, it don't know what is there in the data, but it will treat it as a opcode and give it to the instruction register. In the first machine cycle itself, computer will understand that particular instruction requires how many machine cycles. If that particular instruction requires 3 machine cycles, up to that it will not read again as a opcode. So who is differentiating whether it is opcode or normal data? Computer is differentiating. How it is differentiating? When it is reading the first machine cycle of any instruction, it will read it as a opcode. Okay, Asif? Okay. Now listen. Yes, correct, Bhargavi. See here, T2 state may this 25 number 25 will come and sit on the address bus. Not every line is opcode, Alicha. Okay. Your line, suppose you say move A comma B. इसमें you have opcode and operands. Say or otherwise add 25 is there. In that add is a opcode. 25 is the operand. Okay, just wait. Listen here. So this 25 will come here. Then read bar signal is equal to 1. That is read is completed. Then instruction register will contain the bidirectional data bus contents. What is the bidirectional data bus is having now? This 25 will be coming to the instruction register. Just wait, Amitabh. Just wait. Okay, everybody, I will clear all your doubts. Is what is BDB? Bidirectional data bus. Okay, so memory contents of address bus location. Okay, I will just listen, please. Just listen. I will tell you one example. For example, you have a program like this. Okay, say this is like this. Memory is stored with this. So computer don't know anything. Listen carefully. First time whatever it reads, it will understand it is always opcode. First time the computer read na, that it will understand as a opcode. That it will understand as a opcode. While reading this, it will also understand what is the next byte, whether it is some data or whether I need to write there or something, whether it is what is the value in that. I mean that value meaning it will understand while reading. When it reads this now, it will understand next byte is a data or not. If it okay, if it reads it is a 2 byte instruction. Once it reads, it will read the next as a data only. After that again it will read it as opcode. Now it will understand this while reading this opcode, it will understand it is only 1 byte instruction. So next also it will read it as a opcode. Once it reads now, it will understand. While reading this, it will understand whether the next 2 bytes are opcode or some data. Okay. Now again, same story. So computer don't know anything. Once it reads the opcode, it will understand the size of that instruction, and in that how many bytes are left. After reading the first opcode, it will do that job. And how this opcode is generated, let me give you an example for that also. See here. I have different operations. For example, let me show you some way to generate the code. Add operation, subtract operation, multiply. Multiply is not there here. I am just giving you some example. Okay. And some different ways are there. Each have some name I am giving. 000, 001. Okay. Wait. Correct or no? You have the registers na A, B, C, D, E, F. I am giving them names 000, 001, 010, 011, 100, 101. Okay, some randomly I am giving. Okay, don't worry about it. Now listen. Now listen. Suppose I want to make code for add A comma B. What will be the corresponding code? Take only 2 bits. What is the corresponding code for add A comma B? It should be generated like 00. A comma B na 000. B means 001. If you want to do subtract CD, suppose subtract CD is my instruction. So what will be the code for that? 01. C means 010. D means 011. So this is how opcode will be made by the manufacturer. So this will be coming to the instruction register. Then in this, according to the design, this part will go to some selection circuit, which will select this addition, subtraction, multiplication, and whatever may be. And this part will be going to selection of register, and this part will be going to selection of register. So this is made by the designer itself. Now you understand the internal part of the computer, how your computer understand ones and zeros. This job can be done by your multiplexer kind of circuit, decoder kind of circuit. Good. So this whole week actually opcode generally contains original opcode and operands also sometimes, but we call it as a opcode only. Ah, okay. In this example, it is only 1 byte. Okay, sometimes there can be extra cases. Different cases can be possible. Okay, add to memory locations. There next time we may give memory. Different ways are there. So once it reads na, then the computer will understand whether it is 1 byte or 2 byte or 3 byte instruction. Like this here, 8 bytes, 8 bits are there na. Maybe suppose take 2 bytes extra, which will decide whether it is 1 byte instruction, 2 byte instruction, 3 byte instruction. Okay, forget. Listen. Okay, you don't talk with each other. I am there here. Please listen first. Suppose for this job, 6 bits are already used. There can be another 2 bits. So who will decide whether it is 1 byte instruction or 2 byte instruction or 3 byte instruction to the computer? So total 8 bytes, 8 bits are there. Now some bits will be dedicated for that. Some bits will be dedicated for deciding operation. Some for operands like that. So computer can know that by reading this opcode, because see, you have 8 opcodes. 8 opcodes can make 8 bits. 2 power 8 combinations are possible. Those many different jobs can be done by the computer. You understand this? Shall we move? Now any doubt, ask me. Now I hope you understand how computer understand ones and zeros. See, manufacturer will take care of how to differentiate the instruction based on the number of bytes. That can be done in the 8. This is just my example. It is not 8085. Please listen, Rohit. In this 8 bits, he may dedicate 1 or 2 bits to decide whether it is 1 byte instruction or 2 byte instruction. Or he may decide like this. Please listen. Number 0002 11111 there na, he may code it already. First 10 instructions are 1 byte, next are 2 byte. Yeah, opcode size is 8 byte only. You can, that is your the designer wish. You understand? You have all codes from all zeros to all ones. In that exam, the designer may make it. If the number is less than this, it is 1 byte instruction. If it is here to here, it is a 2 byte instruction. If it is more than this, 3 byte instruction. This design is in your hand only. You can design in a number of ways. So manufacturer also made the design like that. Yes, Amitabh. Different instructions are possible. So let's go further. So the address at which we are going to give the instruction stored in PC. If it copy in the instruction register, correct, Shivam. Address is in the program counter. It will give to the address bus. Address bus will come to memory. Memory will be given to data bus. Data bus will give to the instruction register. That is the job. If you want, I can make that. Where is that? So program counter will be given to the address bus. Then from there, these contents will be copied into data bus. Generally, we keep bracket to understand the contents of this location is copied to data bus. Okay, then from data bus to, you understand, it will go to IR. Simple steps. Okay, here please understand the difference. If I keep bracket and no bracket, if I say PC to A15 to A0, for example, I am saying, okay, this example only. What is that? 3646 and 25. So if I say like that, say PC is equal to 3646. Listen carefully. Then A15 to A0 will become 3646. Now what I am saying is the content of A15 to A0 to the bus, right, Amita? Okay, so content of what is that 3646 will be copied to data bus D7 to D0. What is the content of this? Means pointer, that is 25 will be copied to D7 to D0. You understand the difference between this bracket and the no bracket, like your C programming. Okay, good. So let's move. So it is a 6T state of code fetch. In this case, where is that? I have not loaded or what? I'm sorry. Let me load. Decoding done by decoder after IR. Just remember the architecture. After IR, you have decoder. If you are studying for first time, just draw the figure again. Draw the architecture figure once or twice. Draw the architecture, draw the pin diagram. It will make you good practice. Right. 25 is the opcode. So see here, it is a 6T state opcode fetch. So extra 2T states may this nothing happens about read and all, but the computer will do some extra job. Why that job required? Just wait for some time. When we discuss the instruction set, I will tell you. While decoding the fourth T state, computer will understand whether two more T states are required for completing the job or not required. Okay. I'm not talking anything about execute. That also we discuss when we discuss the instruction set only. Everything will be crystal clear for you. Don't worry about it. Some instructions require 60, some require 40. Why 6 is required? We will discuss it in the instruction set later. The next one. So what we are going to discuss next is memory read. Okay. So how computer will perform memory read? Okay. Opcode fetch is also one kind of memory read. For understanding memory read, I will give you one example. Please listen. Please listen carefully. Suppose I have an instruction LDA 2000. What does it mean is load accumulator from 2000 location. This is the instruction of 8085, for example. Listen. So how you write this program is like this. Okay. So in this case, then computer will go to 2000 and some 44, some number is there, whatever maybe, leave it. So this is at some what randomly I am taking. It is some random number I am taking. This is the address data. Please understand, address can be any size, data can be any size. There is no link between address size and data size. Address is number of locations. Data is each location how many bits. Okay. Suppose this example we take. First, what it will do? Opcode fetch. It understand it is a 3 byte instruction, means this instruction contains some part also. We should read that part also. It will read this. What is this called? Memory read. It will read this. Memory read. Please observe carefully. It is reading from memory. What is that? 8001 and 8002. But what it is reading? 2000. It is reading data. But originally, what is 2000? Okay. For computer, it is a number. For us, it is an address. So computer don't differentiate those things. It is depending on the instruction. We are the designers. We should make those things. So memory may everything numbers only. Memory don't know whether it is opcode or address or anything. Memory is useful for writing the numbers, ones and zeros. That ones and zeros different ways may it will help us in the different ways. Okay, people. Okay, so this address is stored in two parts here. Okay, 16-bit cannot be stored in one location. Maybe that is your doubt, people. Okay, so this 00 computer will read like a data. Computer don't know anything. Once it reads, okay, because of this instruction, it will go there, pointer concept, and it will read. It is 3 byte only. This is not part of instruction. It is not 4 byte. Okay, it is outside. Then it will go there and it will read another memory read also. It will do. So our question here is, our discussion here is memory read machine cycle. That is how this job will be done by the computer. What are the steps involved in doing this memory read? Now don't worry about what is LDA. We will discuss that later. This is just for your example I am giving. Now our job is to understand what is memory read, how memory read happens in your computer. So let's go. For memory read, your S1 S0 should be 10. Memory should be 0. Thank you, Deep. Okay, read bar signal should be 0. These things you should get. Okay, Aditya. So now come here. End of the day, everybody will be able to understand. Don't worry about it. Okay, now listen. Same story. IO member is 0. Here it is 1. Here S1 will be 1, S0 will be 0, as I told you there in the table. So first part my higher order bus. Second part. Okay, second part lower order bus. Okay, same story. Address latch enable is done, then data from the memory. Okay, it will read the data from the memory up to read bar signal. Sir, where this memory will be gone, sir? Where it will keep this memory, sir? ALE itself, pulse man, why it is triggering? No, it is not IR. IR is used only during machine opcode fetch. Opcode fetch may only it will use IR. Now it may be temporary register, it may be W register, it may be Z register. It depends on the instruction. It purely depends on the instruction. Okay, I will show you that when we discuss the instruction set. Okay, here it is not IR. Here it is not to IR. So once you understand this, it is not difficult now. Okay, yes or no? It is same repetition, but only this thing changed. It is 10. And now it is not to instruction register. It will read and it will where it will keep it generally maybe temporary register or some other register depending on the instruction. It depends on the instruction. Okay. One minute, Pupul, what is your doubt? 2 cycles. It is 3 T states, na? Here also, earlier also it is same. Okay, it will start at the T2 and at the T3 during T3. Okay, see step by steps. Listen here. First T state address is copied by the same story as previous case. So the memory or contents of the address bus. The memory pointed by the address bus. Contents of 1 minute here. Just listen, just wait. Contents of memory pointed by address bus. Very good, Chaitanya. This is where you need to apply your common sense. Memory read machine cycle. Okay, right. Even I don't know, even I don't say, you should be able to understand those things. Next, read bar signal is 0, it will copy it. Read bar, it is internal register, not instruction register. Good. It can be W, it can be Z, it can be something else. It purely depends on the particular instruction. Okay, is it clear? Now, another case also I showed here. What is that? Is not every time PC will be incremented. Second case may I have not shown, like stack operations. Sometimes this is also possible. It is not general case every time. In this, there is another case also where it may not increment. Program counter may not be incremented. Okay, some other register pair may be used. Okay, this kind of condition is also possible. Not only HL, it can be any other also. I will show you those conditions. For time being, just think that not only PC, sometimes there is a possibility other than PC can also be loaded. I told SP also, na, stack pointer. So some cases there is a possibility other than PC also. In those cases, PC will not be incremented by 1. That is what I showed here. Okay, so good. So let's go to the next. Anything else? BDB means bidirectional data bus. Both are same only. HL is having address. That is the meaning. That's why he kept bracket is there. You observe. Okay, let's go. Let's go to the next new slide. Why it is not happening? Right. Memory read is completed. Now memory right. Now you understand. If you understand one thing, remaining things will come on its own. Only opcode fetch if people will live at there itself because the figure looks complex. If you understand that, remaining all will come easily for you. See, here only difference is instead of read signal, we give write signal. There 1 0, here it is 0 1. These are the things for memory write machine cycle. Good. Here reverse here different thing. What is the difference here is data will be given to the memory. Here your D7 to D0 will be given to the memory. Okay. So earlier I told load, here we can say store. In that case, the accumulator content will be coming and writing into the memory. See, in the T3, write operation will happen. In T2, the data from your what we call memory write means what? From CPU. Please listen. From CPU to memory. Okay. So it may be accumulator or anything. From accumulator or somewhere it will come to memory. So during this time, accumulator or whatever you are having, that data will come to the data bus. Then in the T3, once write is completed, T3 may what happens is the particular data will be written. It can write anywhere. Read and write are not same of independent operation. Don't see here. Where to write is given in the instruction. Say I say store accumulator in 5000. So computer will go to 5000 and write there. Okay. So I am giving you this example. See here, store accumulator into 5000. Okay, Asif, let's take one example. Store accumulator into location 5000. Okay. Address is required, man. What is the doubt? Amitabh, listen, just listen. You have opcode. 5000 will be there. Please listen. First, it will have opcode fetch. Normal memory reads will happen here. Then it will come to 5000. It will write. Already it may have some value. Suppose accumulator is having some 30. Okay, this accumulator will be copied here with this number 30. This is what we call memory write. In T1 itself, address will be loaded. In T2, data bus will be loaded. In T3, memory will be loaded. Yeah, overwritten. Whatever there will be overwritten. Okay. T1, T2, T3 of this part we are discussing. This will happen before. This is another machine cycle. This is another machine cycle. These things happens already in different machine cycles. We are speaking only about this. Please understand. It is one machine cycle. This is one machine cycle. This is one machine cycle. These things will happen. After that, this cycle will come. In this cycle, what happens is first this 5000 is there now. That will be given to the address bus. Then it is accumulator whose value will be copied into the memory. So accumulator is having some number 30. That 30 will be copied into 5000. What is the meaning of this instruction? Store accumulator value in 5000 location. So computer will read this opcode. It will understand. It need to do store operation. 5000 means it will read these two things. It will get that number. Maybe it is storing in W and Z, anything. Okay. Then in the first T state, what happens? Higher order address bus and lower order address bus will be copied with 5000. Second T state, the accumulator number is there, na, that number will come. And we will be writing it into the where the required memory. It can store anywhere. There are different registers. It can be temporary register, WZ. It depends on the instruction. Last step is write into the memory. Amitabh. Wait, don't worry. Where is Udit? Wait. Listen here. What is the meaning of this instruction? Understand. Okay, LD and STA are opposite to each other. STA means store accumulator. What is accumulator? Is a register. That fellow is already having some number 30. Okay, example I have taken. This 30 is to be stored into the memory location 5000. First, understand the meaning of the instruction. For example, you have an instruction store accumulator value into 5000. Now you understand? So whatever I am having in the accumulator is to be stored into 5000 location. That is my job to be done. Now then for that computer will have program like this. Opcode will be there. Computer will understand this is the job to be done. Then the next two will be read. These two, this 5000 will be kept in some WZ register or any temporary register. It depends on the instruction. Okay. Here it is a WZ may, it will keep this 5000. Then This 5000 after this job, now it should write what is that number 30 into the memory. Last step may what it need to do, the value of accumulator. Store means write the value of the accumulator into 5000 location. Store it in the 5000 location. Store it in the fridge. Keep it in the fridge like that. Store it in the memory. Keep that 30. Bring that 30 and keep it in the memory. So accumulator will give to data bus. That will be given to this memory. You understand now? So writing it into the memory, that's why it is called memory write operation. Yes, correct, Chaitanya. Please understand one more thing. This is one machine cycle. This is one machine cycle. This is not T1, T2, T3. Please listen. Some misconception might be there. It is not T1, T2, T3, T4. It is separate machine cycles. It is separate machine cycle. It requires 4 T states. It requires 3 T states. It requires 3 T states. After doing this job, this is fresh. Freshly, it requires extra 3 T states. Correct, Ruchita. So for in this particular instruction, how many machine cycles are there? 4. One opcode fetch is there, one memory read is there, another memory read is there, another memory write. Don't take it as 4 T states. These are 4 machine cycles. Got it? So memory write is a part of an instruction. You need to read 5000, Rohit. 5000 cannot be read. 5000 is a 16 bit. You can read only 8 bit at a time. So 00 is to be read and 50 is to be read. No, only one instruction. Completely one instruction. Abhijit. This is completely one instruction, which is containing subsets. How many? 4. Yes, correct, Abhijit. So shall we move further? Good. Correct, Lucky. Yes, Aditya. Listen, I am writing that. Don't worry. One instruction can have many machine cycles. One machine cycle contains one. Okay, I'm sorry. Many T states. Good. So let's move to the next. No, read and write are part of same instruction. Instruction is not read write. This complete job is one instruction. Abhinit. For doing this job, see here, read it as a job. Read it as a job. Okay. STA 5000 is your job. What is this job is telling? It should store accumulator into 5000. So first you need to read 5000 because you don't know this address now. So this job requires opcode fetch, reading this 5000. Okay, read this number 5000 and go to 5000 number and write the data. Everything all comes under one instruction. Okay, next. Similarly, listen here. Similarly, IO read, IO write with IO by M bar is equal to 1. Difference kya? IO by M bar will be equal to 1. Okay. Earlier here a memory operation, so M equal to 0. Here IO operation, IO by M bar will be 1. So remaining storage is the same. Right. So next, what we are want to discuss here. Interfacing. One minute. Okay. Just wait a minute. So memory interfacing. What we are going to discuss here. What we are going to discuss. How to interface memory devices to the computer. Every year, some question, okay, frequently occurring part of 8085. Because this year there is a chance of normalization, what we call multiple times your exam can happen. If that happens, you should read everything. Why? Because you don't know your set get a memory interfacing question or instruction set question. You don't have choice. So you may be left leaving one part. That part may come in your exam. Abhinay, whatever your doubt is there, we'll discuss it back. I mean, let me complete it first. Okay. So this is easy also. This part is easy also. Let's discuss it. Okay. So let's take one memory chip. Say it is having 1 KB. What is meaning of 1 KB? 2 power 10 into 8. Okay. What does it mean? 2 power 10 locations. Each location 8 bits. Is it clear? Right. So now listen. So here you need 10 address lines. A9 to A10, A0. How many address lines? 10 address lines. Each location 1, 2, 3, 4, 5, 6, 7, 8 bits. Okay. Now you understand. It is having uh, a data bus of size D7 to D9. We can draw it here. Just wait. Okay. So this is the data bus we are having D7 to D0. Okay. How many bits? 8 bits. Okay. So this is how your 1 KB memory IC will be there. Okay. So now what we want to discuss here is just how to interface memory chips to the computer. You have a 8085 computer. How to interface different memory chips to the computer. Just wait, I can reconnect to. Okay, leave it. Is this point clear? Just basic. Okay. So now let's start. Let's start with memory interfacing is like pen drive. Okay, how to connect your memory device to the computer? Different ways. Okay, now in this first one, we want to discuss is memory expansion. Okay, what I want to discuss first initially memory expansion. What is memory expansion, sir? Memory expansion is nothing but you have one kind of memory, how to make another kind of memory. You have RAM, okay, of 2 KB. How to make it as a 8 KB? I mean, how to connect 4 2 KBs and to make a 8 KB like that. So let's discuss that. 1 minute. Okay, 1 minute. Implement. Just listen, you can understand. Implement 8 KB memory using 2716 IC. It is not required to remember, but I will tell you. 2716 means 27 will say it is a EEPROM. 16 by 2 is the size. So 16 by 8 is the size. 2 KB. So 2 KB is the size of the memory. You have 2 KB memory. How to make 8 KB memory? Another we have is a 6116 IC. 61 will tells it is a RAM. Just general specifications. It is a standard IC. Even you don't remember, no problem. So question is like that. You have 2 KB memory. How to make it as a 8 KB memory? I need to take some. Yeah. So let's see how to do it. This part is easiest part of your 8086. Add 6K. Okay. Or take, see here firstly. How to add is the main job. You cannot add, take it and add it now. So and interface to 8085. Okay. So now listen here. Number of, this is important, ICs required is equal to desired size by available size. Desired size kya? 8 KB. 8 means 2 power 13. Yes, correct. 2 power 3 is 8 now, 2 power 10 is 1K. Remember that. So by 2 KB, 2 means 2 power 1, which will give you 2 power 2 into 1. How many are required for us? 4 chips are required. Okay, right. Okay, leave it. Let's go further. So 2 KB means 11 address pins. Okay, 2 KB will have 11 address pins. Let's have here also. If you have 10 pins, just listen, 10 pins, A9, A8, A7, A6, A5, 4, 3, 2, 1, 0. You can have all zeros to all ones. Okay, please listen here. No internal memory is there. It is 3 in the hexadecimal. It is F. It is F. This is 0, 0, 0. So 1 KB is having the range from 0, 0, 0, 0 to this is the address range of 1 KB. This is the decimal name 0. What is this decimal equivalent is 1023 because 2 power 10 is 1024. If you want, you can convert it to decimal and check it. So let's come here. Okay, so you have next. If you have 8K, it is a 13-bit required. Okay, so now let's do it. A15, A15, 14, 13, and 12. A11, A10, A9, A8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. Now listen here. Now here, 13 bits. So 13 bits means you take first all zeros. 1. Okay. To all ones. 13 zeros to 13 ones is the address. Okay. Please listen. In this case, it is not required, but I am giving you. Please listen. Now, what about the remaining bits? Why I am taking 16 bits? Because our 8085 is having 16 bits. Okay. Now, this is 0, 0, 0, and 0. This is 1, F, 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 hexadecimal. So it is a 0000 to 1, F, 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 hexadecimal. Is all zeros to 1F FF hexadecimal. Okay, so now listen here. Listen here. In this, you are having 11 bits, that is 0 to 10. The remaining, these 2 bits are there. Just wait first. These 2 bits are there. They can be 0001, 1011. Okay, these are used for chip selection. These are used for chip selection. Okay, so they can be 0001, 1011. Okay, just listen. How many chips are required? What is your required size is 8 KB. What is your available size is 2 KB. 8 by 2 is 4. 8 means 2 power 13 and 2 is 2 power 11. Okay, now see here. Now see here how to construct this circuit. So take 4 ICs. Give equal area. Okay, and here use some 2 to 4 decoder. For this decoder, you give this pins A12 and A11. Okay. Now, for this, it has 4 possibilities 0, 1, 2, 3, and you have enable input. This enable input, you take a AND gate, and here you connect the first 3 bits. First 3 bits should be how much? 0, 0, 0. Na? So A, 15, 14, 13. They must be 0, 0, 0. You will get 1. If it is enable bar, we take bubble. No problem. So now what we do? You take this one. ROM is there now. So ROM 0, ROM 1, 2, and 3. So in this part is common. What is that part? A10 to A0. This is 2 kb. So in this 2 kb, okay, A10 to A0 is common. Okay, what do you do with mux? Multiple single output will come. Here single say multiple required. Aditya. So here also it is 11 pins. It is having 11 pins. What is that? Giving the address bus A10 to A0. A10 to A0. A10 to. Okay. Now listen. So here we give this to CS. CS means chip selection. It's nothing but enable. What is the meaning of CS? Chip selection. So now what you can do? Now this is 8-bit data bus. All these data buses can be connected together. Okay. Even when you give the particular address, okay, that particular suppose if it is 0, 0, only this part will be enabled, remaining will be disabled, and this A10 to A0 will decide what is the data you will be getting. If it is any one of them will be selected, not all will be selected at a time. Here, this is one method how to make your 8 KB RAM using 4 KB. You understand? Okay. So listen, Rohit. Your 2 KB you are having 2 KB is having only 11 pins. What are the 11 pins? 0 to 10 only. But 8 KB requires 13 pins, 0 to 12. So 0 to 10 will select 2 KB. But in that 2 KB, you have 4 2 KBs. Out of the 4, you should select one. For that, you need 2 bits that are A12 and A11. When A12 can be 0 0, 0 1, 1 0, 1 1. So to select first chip or second chip or third chip, you will be using this A12 and A11. Is it clear? Any doubt, Amitabh? Amitabh, A60, A15 to A0 is our address pins. Clear? Good. So if you are see here, if it is 00 first chip, 01 means second chip, 10 next chip, 11 last chip. Okay. People, if you want range, a simple thing. Keep here 00. Next time you keep this 00, you change this all zeros to all ones. Next keep 01, all zeros to all ones. Next 10, all zeros to all ones. 11, all zeros to all ones. That's all. That we discuss in the memory mapping topic anyway. Okay, next. Let me do one more thing. Next question. Implement. Thank you, Bubble. 1024 into 8. That is, what is that 10248? 1 KB memory using 1024 into 4 size memory. You have this, but you need this. How to do it? Listen, same story. How many ICs are required? 2 to the power of 10 into 8 by 2 to the power of 10 into 4. So 1 by 2. Just 2. Okay. You don't need decoder here. Listen. Just listen. Just wait. You have this 1024 into 4. This is 1024 into 4. Here you have the address bus A10 to A0. Here A, not A10, I'm sorry. A9 to A0. Here also A9 to A0. Okay. And this fellow will give 4 bits. D7 to D0, and this fellow will give D3 to. Okay. Now remaining are used for chip selection. Here chip selection is common. A15, 14, 8. Okay. So this is the chip selection. Now listen here. Listen here. You have this. This is called horizontal expansion, and the previous case is called vertical expansion. Here, data bus. Data bus common, because all the data buses are together. Here, what is common? Same address bus, but data is divided into parts. Okay, here both will be selected same time. This is called horizontal expansion. This is called vertical. Here any one of them will be selected, not all. Here rows, here columns. Okay, so you can see where we are. You can see here in this multiplication, you got 2 power 2 into 1. This will tell you number of rows and columns. This will tell you how many vertical, how many horizontal. Here also, how many vertical, how many horizontal, how many rows, how many columns. How many rows? One row. How many columns? Two columns. So don't cross divide this. Okay, don't divide this 4 with this simultaneously. Correct, Aditya? Now let's do more number of questions. Let's do more number of questions. Downloads. Yeah. Let me upload the questions. Just wait. Let me download the questions. Yes, I got it. Sorry for the delay. We are able to download the questions and now we'll start doing the questions. Get ready, guys. Let's make all the questions. Change the theme. Yeah, let me upload all the questions, then we can take them. So this question I like much. So let's start with this question. Read that question. I will start the poll. Get ready. Are you ready? Poll. Yes, start the poll. Where is the good? What happened? Only 15, 10%, 15% gave right answer. Is it really that much tough? Do you feel this question that much tough? Let's see. You have a memory system of 64 KB. It is to be designed using a chips of 1 KB and a decoder tree. It's a combination of your digital circuits also. Okay, and with a 2x4 decoder. Okay, let's do it. Let's do it. So here, what is the formula? Same number of chips by available 1 KB. You understand 64 is 2 power 6. So to select, okay, 64 chips. So what is the decoder? You are able to, I mean, note earlier you had 64 chips. So what is the decoder required is a 6 by 64 decoder. Earlier you have 4 chips. Sorry, wait guys. You are able to, I mean, no interruption. Huh? Okay, power is gone, no issue. So earlier you have what I want to say 64 decoder, your job is done. To get this 6 by 64 decoder, see, take 6 by 64. Take 6 by using what? 2 by 4. So I told the formula earlier in the basics of the your digital. So total 21. That is the question. Any doubt, please ask. You require 64 chips, but select 64 chips. I need 6 by 64. 10 address lines are directly used. The 6 address lines are given to decoder. Okay, 6 by 64 decoder is required. But you have, what is the decoder you are having? 2 by 4 only. So to get to 2 by 6 by 64 using 2 by 4, divide 64 with 4, 16 by 4, 4 by 4 stop. This process we discussed in the digital logic earlier. So is it okay? Shall we move further? 1 minute, Shivam. Here, how many chips are required? 4 chips. That's why to select 4 chips, you need a 2 by 4 decoder. To select 4 chips, you need a 2 by 4 decoder. Similarly, here how many chips are there? 64. I need to activate one chip at a time. To get 64, you need to have 6 by 64 decoder. That much simple. Got it? One special class at 10 p.m. for a second, third years. They can come. Okay. So start the poll. Yeah, it is a simple question. You need 1 MB. 1 MB means 2 power 20. What do you have? 64. So you require 2 power 4 by 1. That is 16 into 1. These are rows. Sorry, I'm sorry. These are vertical. These are horizontal. These are rows. These are columns. So you should have 16 rows. 16 rows means you will get like this. Okay. 16 rows will give you one column. That is the logic. Don't think 16 rows. Okay, 16 in a row. 16 rows is different. 16 in a row is different. It is MB, it is KB. What is the problem? What is the problem? क्या हुआ? अरे B or MB, what is your problem? MB is greater than KB, yeah. Megabyte. 1 megabyte is 2 power 20. Mega means powers 10 power 6 na. 10 power 3 is KB. That will give you approximately 2 power 10. So 10 power 6 will give you approximately 2 power 20. 1 KB into 1 KB is 1 MB. 1 KB into 1 KB, that is 2 power 10 into 2 power 10 will give you 1 MB. This B is bytes. By default, nothing specified. B is bytes only. Capital B or small b, don't worry. Whether it is, if it is B, it is bytes only. Okay. So 2 power 20 into 8 by 2 power 16. I'm sorry. This is 2 power 16 into 8. That will give you 2 power 4 into 1. 2 power 4 is a 16. 16 rows. 16 rows. One column. It is in a column. 16 ICs in a single column. Any doubt? Good. So I have loaded these questions. You can try. Tomorrow we will continue. I have another class now, so tomorrow we will continue. No problem. You can make it as a practice. We'll discuss the memory interfacing tomorrow, instruction set also tomorrow. And yeah, you can ask Aditya. Let me clear Abhinay doubt. Abhinay, you are there? So for memory write machine, good night, guys. Abhinay is having some doubt. Let me clear that. Hmm. All doubts must be cleared before going. Special class is English, Hindi only, no Telugu. That is only for YouTube people. Just okay. For now, special class is in pure Hindi or English. You whatever you are comfortable, you ask him. I forgot to upload this as Abhinay. I don't know whether he is there or not. In T2 states, right bar will be 0. Okay. Your internal UP means microprocessor internal register will be copied to address bus. When right bar becomes 1, then that address bus contents will be transferred to the memory. You got it now? Fine. What happened, Asif? Yeah, any other doubts? Ask. Sure, Ankit. You have messaged me already in an academy. I will check it. Okay, if no other doubts are there, we can. Aditya, something is there? Yeah, what is the doubt in that 6 by 64? If it is 4 chips, it is a 2 by 4 decoder is selected, required to select 4. That is a n chips, you need n. Okay, if you have n chips, n into 2 power n decoders. Okay. So if you have here n is 6, 2 power n is 64. What is the doubt in this, Aditya? Got it? Here n is 2 power n is 4 here. Similarly, 2 power n is here 64. Right. So that's all for today. We'll meet tomorrow. Tomorrow we'll be starting instruction set also. Memory interfacing will be completed. Then we start the main part, instruction set of 808. Okay, bye bye.